In the last few videos, we've been using technology to see linear versus quadratic graphs. We've talked about function notation, and we've looked at patterns in tables of values. And now in this video, we're going to talk about the different forms of linear and quadratic equations. We're back to the harder equations, but before we graph them and try to visualize what we're seeing, let's match the equations with the different forms first. We'll talk about 3 different forms of the linear equations. We'll see if we can match up the letters on the left with the numbers on the right. First equation is called the slope-intercept form. And we love that one because we can see 2 things. We can see the slope and we can see the y-intercept right there. In our equations, 1/4 is the slope and -5 is the y-intercept. If we want to see the slope y-intercept, we can certainly convert all of these equations to the y equals mx plus b form, but the other equations can be used as well to find the important information. The second equation is called the point slope form, or the slope point, and we can see the slope with that one too. We can match up the letter m in the second equation as well. The slope is 4. And the point we're dealing with, we have the 1 showing and the other one is not showing. It's a 0 in our equation. We can read off a point. The point becomes -1 for the x1 and 0 for the y value. The third equation is written in that form as well, only this -5 should be over on the other side. Y plus 5 equals 4 bracket x plus 1. We can see the slope is 4 and the point is -1 comma -5 from our equation. Fourth one is written in the point slope form. We can see the slope is 7 and the point on the line is 3 comma -1. We just switch the signs because the equation has negatives. And the last 2 aren't written in the form I've given, but we can certainly rewrite the 2 to be 2x plus 3y minus 6 equals 0 and x plus 3y minus 12 equals 0. And if we do that, we can see the a value, the b value, and the c value in our line. A is 2, b is 3, c is -6. And in the second one, A is 1, B is 3, and C is -12. That's a little review on different forms of linear equations. I've entered in all of these equations, and I want you to think about what they might look like. Are they lines? There's our parent. We have some changes. The steepness changes for those. The movement changes. We've got some that are exactly the same. These 2 are exactly the same. These 3 are exactly the same. This one, and that one, all the same. That one, same. That one, same. All of these are lines. Similar to linear equations, quadratic equations can be written in different forms. The first form we call the vertex form, usually. Second one is the factored form. And the third one is the standard form. Of course, different resources may call them different things, but I'm going to stick to these words. Now for the quadratics. The shapes, when we have an x squared, or degree 2, are from the quadratic equations, and we call these shapes parabolas. There's our parent, and from there, we can think about what happens when we put some different coefficients in, or constants. Now look at that one. Remember we talked about the 1/4, how it pushes the graph down, or compresses it, or shrinks it? We have a movement down 5 as well. The compression always happens first, and then we move. That was that one. We have a vertical stretch of a 4, and then we have a movement. Notice how the movement is opposite from what we see. Now we go down 5. The A value is 4 in both. The shape is the same. Here are our last 3 that we had showing where we could see something called the R1 and the R2. The R1 and the R2 are called roots, and we'll be seeing that the roots of a quadratic equation end up being the x-intercepts if we graph the parabola. That's kind of interesting. The only thing we can see from the last 2 when we graph is that the shape is the same because the A value is 1, same as in the parent, but we really don't know what the picture looks like just by showing these 2, although we do know how to factor x plus 3 squared. We get the same shape, the exact same parabola. Anyway, we'll see that later on. Do you remember when I said that we need to be able to look at an equation and understand what it looks like without graphing? Well, here's how we do it. We can talk about transformations. Y is equal to mx plus b is an important form. For quadratics, y is equal to a bracket x minus p squared plus q. Some resources will use h and k for those values instead of pq. When we looked at the line, we know we have a slope of 1/4. The graph became less steep and the graph moved down 5 vertically. For the quadratic, we have the same thing going on. The A value makes the graph sort of less steep, compressed vertically, and then we have movement down 5. -5 means down 5. We're going to, with this one, get less steep and then down 5. Is that what happened? Yeah. So we went less steep and down 5. So the slope became rise up 1, run over 1, 2, 3, 4. That agrees. And now the quadratic, see what happens. We end up getting compressed and then down 5. It's easy to see that transformation because we just look at this lowest point right there. When we have brackets inside, like this, when x is replaced with an x plus something or an x minus something, if we compare to the graph here, what we can say is, first off, we have a stretch vertically because we have the 4. But now inside the brackets, what we can say is we have movement left 1, or a horizontal movement. Horizontal. We can think of that with the line as well. The line gets more steep, but then we have movement left 1. We could rewrite y equals mx plus b. We could say y equals 4x plus 4. We have a stretch, but then we go up 4. That will correspond with the moving left 1 as well. For the line, we have a 4 in the front, so of course it's going to get steeper. And we have a movement from there. We went left 1. So we were here, we became steeper, and then we went left 1. It shows plus in here, but that means move to the left. And that same thing can be seen with the quadratic. We're going to get steeper, and we're going to move left 1. And this one's nice. This bottom part here, this minimum point, just moves left 1. Quadratic, we have a 4. We're stretching vertically. And now we have 2 movements. We have a movement down 5, but we also have a movement left 1. And for the line, we have a more steep, and we have a movement left 1, down 5. Also, we can rewrite this as y is equal to 4x plus 4 by distributing minus the 5. It's 4x minus 1. We're steeper, but we're going down 1 as well. So we can think of it 2 ways. For the line transformations, I'm going to take it one step at a time. So if we go and make the line steeper, then go left 1, and then go down 5, we end up there. It's a weird one that you kind of have to take it in stages. The x squared, make it steeper, and then go left 1, down 5. That's easy to see. So in some ways, the quadratic transformations are easy to see, aren't they? Because we have that minimum point there. Now for these ones, we can't really see what's going on with our equations. We do not have the quadratics written this way. We can't describe the transformations here. If we rewrite y is equal to 7 bracket x minus 3 minus 1, we could say that the graph is more steep because the slope is 7, up 7 over 1. We've moved right 3 and down 1 for that one. Definitely. If we rewrote it as y equals 7x minus 21 minus 1, we still see the same slope, but the y-intercept is negative 22. We're moving down 22. If we take a look at the final line, we can't even see the y-intercept. We can rewrite that equation just by moving that 1 over and making it negative 1 on the right side. Let's actually see what happens in stages. So the first thing we do with the line is we make it steeper, and then we go right 3. And then finally we go down 1. And there it is. Well, that ends up having a y-intercept of negative 22. And that agrees with the equation, because if you distribute the 7, you get negative 21 minus 1 is the negative 22. So that works. So again, this one, this one, this one, and this one, we can't see anything to help us visualize what the graph is. So we need to rearrange or write the equation in a different way. Perhaps we can try to write the quadratics that way. And of course, in previous courses, you did isolate the y in this equation, didn't you? You went 3y equals negative 2x plus 6, divide by 3, negative 2/3 x plus 2. Now we can see the slope and the y-intercept. And then this one, same thing, 3y equals negative x plus 12. Divide by 3 both sides, negative 1/3 x plus 4. And that's what we saw in Desmos when I showed you the different forms. Anyway, so moving forward, definitely we can use certain forms of the equations to picture the graph, but then others don't help us at all. Wow, we talked about a lot of things here in this little session. We talked about linear equations versus quadratic equations, degree 1 versus degree 2. We reviewed all the different forms of the lines and learned about the different forms of quadratics. We're going to learn a lot more in this quadratic section. And I hope that you come back to this video because I threw a lot of stuff at you, and you'll probably need to rewatch at least parts of it throughout your learning. And then all of this will hopefully become a little bit more clear as we move forward. Great work.